Okay, we are back. There is some homework. The homework is to finish the rest of this antidifferentiation packet, specifically pages 2 through 7. On the video that you hopefully already watched, or probably did, I did most of the problems. I left you really not that many. So if you're watching this, I hope you're just not watching this. If you are, hopefully you did all these problems yourself and you're watching on like 4 times speed or something just to check the answers. But here we go. I did promise I would do them all, so I'm going to do them all. These are all the problems from the packet that I didn't do in the video. Number 10, I'll go kind of fast. This is the antiderivative of ln x dx over x. Well, does it look like some chain rule happened here? Yeah, it really does, because if you let u be ln x, then du dx is 1 over x. And so du is just 1 over x dx. And that's exactly what's sitting here. And so in fact this whole problem just becomes u du. Answer 1/2 u squared plus c. So real answer 1/2 ln x squared plus c. Okay, good. 11 is almost the same problem. Yeah, it's like almost the same problem. It's x root ln x. Well, once again, does it look like some chain rule happened here? Yeah, it does. Because if I let u be ln x, then du is 1 over x dx, and that's what's just right there. And so this whole thing becomes du over root u. In other words, u to the negative 1/2 du, and that can be antidifferentiated by going up a power to 1/2 and dividing by the power, so that's 2 root u plus c. So final answer 2 root ln x plus c. I guess is the answer. Yeah. Woo. Okay, more. 12. A little bit of a silly problem. Here it is. Cosine x times the cosine of the sine of x. Something that's almost meaningless. Does it look like some chain rule happened here? It absolutely does. Because if I let u be sine, the inner function, then du is cosine x dx, and that's right there. So actually this whole problem becomes cosine u du, and the antiderivative of cosine is sine. So we get sine u plus c, real answer, the sine of x plus c. Okay, boom boom and boom boom boom. Good. 3 down, some to go. 13. Okay, what's this? E to the x over e to the x plus 1. This might confuse you maybe for a moment. What's going on here? Hard to say. Well, the derivative of e to the x is e to the x, and so the derivative of e to the x plus 1 is also e to the x. So if I just let u be e to the x plus 1, then du dx is just e to the x, and so du is e to the x dx. Okay, therefore, it does look like some chain rule happened here because the numerator is in fact just the derivative of the denominator. I guess that's the idea. So this is du over, well, just u. So answer, ln absolute value u, so u, boom, 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 plus c. And I don't think there's any way to simplify that anymore. 14, okay. Arctan, antiderivative, arctan x over 1 plus x squared. Well, now I just know that 1 over 1 plus x squared is the derivative of arctan. So if I just let u be arctan, then du is just 1 over x squared plus 1 dx. And therefore this whole thing is just u du. So u du, and we know that the antiderivative of u du is 1/2 u squared plus c, so this becomes 1/2 arctan squared. I just do this plus c. Whew. Okay. Good. Let's see. 15. Okay, 15 is another good problem where you could kind of just do this in your head, or you could do a u sub, I suppose. So the the problem is, what's the antiderivative of 5 to the x? Okay, well, you have to know some things. You have to know that the derivative of 5 to the x is ln 5 to the x. And so, you might be tempted to just do this all in one step, because the derivative of 5 to the x is, roughly speaking, 5 to the x, give or take a constant. So, the answer to this problem is kind of like 5 to the x plus c, but not quite, because when you differentiate this, you get this extra ln 5. So if you throw in a little 1 over ln 5, now it's just good. Okay, and that's totally correct. If you want a little bit more systematic way of doing it, I suppose you could do a u sub. You could let u be 5 to the x. Some people find this confusing though. Then what's the derivative of 5 to the x? Well, like I just said, it's ln 5 times 5 to the x. And so du is, well, it's ln 5 times 5 to the x dx. In other words, it's almost what's in there, but not quite. So I need to stick in an ln 5 and undo the damage with a 1 over ln 5, which is, after all, just a number. And if I do that, then what I'm left with is 1 over ln 5 antiderivative. Well, that whole thing is just du, right? ln 5 times 5 to the x dx is just du. And that's why the answer is 1 over ln 5 times the antiderivative of du is just u. And that's why the real answer is 1 over ln 5 times 5 to the x plus c. Chop. Okay. Good. 16, 17, 18. Let's go. 16. This is tan squared x secant squared x dx. Okay, this might strike you maybe as a little tricky, but okay. You know, the derivative of tan is secant squared. And so it very much looks like some chain rule happened here. Because if I let u be tan, then du dx is secant squared. And so du is secant squared x dx, and so this whole thing becomes u squared du. Ta-da! And thus we get 1/3 u cubed plus c, or 1/3 tan x cubed plus c. Okay? 17 and 18 are maybe slightly tricky because of algebra, but okay. What's going on? Let's see. 10 root x over 1 plus x to the 3/2 squared. Yikes. And then I think there's a typo. I forgot the dx in there. Okay, now what? Does it look like some chain rule happened here? Well, it does. Because the derivative of x to the 3/2 is, give or take a constant, root x. And therefore, yeah. So therefore, I want to let u be 1 plus x to the 3/2. And if I do that, well, du dx is 3/2 x to the 2/3. And so du is 3/2 x to the 2/3 du. Sorry, dx. Okay, and now I guess I'm sorry, that's just all wrong what I said. The derivative, derivative of x to the 3/2 is 3/2 x to the 1/2, is what I meant to say. Good. Okay, now I don't quite have a 3/2 there, so I need to stick it in. So I stick in the 3/2 and I undo the damage with the 2/3. So I hope we're getting kind of better at this. I hope I'm showing enough steps. I think I am. So now I'm going to take out the 10, so that becomes 20/3 antiderivative. I took out the 10, so I'm left with 3/2 root x dx, which is exactly the du. So this becomes du over u squared. And I'll do one more thing where I rewrite this in anti-differentiation friendly form as u to the -2, which I think is helpful because it helps you remember the rule. You go up a power, you divide by that number. So up a power would be u to the -1, you divide by -1. So it's -20/3 u to the -1 plus c. So, or -20 over 3u plus c. And therefore the real answer to this problem is -20 over 3, 1 plus x to the 3/2 plus c. Okay, 18 is quite tricky, I think. People have seen this before and not known what to do. It's a little bit of a mean problem. What's going on here? Sine of 10x times e to the sine squared 5x. Okay, well, what's going on here? Well, there are multiple composite functions. There's this e to the function, and the inner function is sine squared 5x, which is itself a composite function. It's the square of sine of 5x, which is also a composite function. So this is actually like sort of 4 function compositions deep, right? Inner function being 5, outer function sine, outer function squared, and then e to the. So there's a lot going on. Does it look like some chain rule happened here? Not absolutely obviously so, but yeah, it would be really nice if I could just let that whole exponent be u. And I think I just can, because if u is sine squared 5x, so really this is just sort of an exercise in the chain rule, so then u is really like sine of 5x quantity squared. So now what happens when I differentiate that is I get 2, the derivative of something squared is 2 something back inside for the derivative of the something, and what's the derivative of sine 5x? It is cosine 5x back inside 5. Okay, and so what I get is that du is 2 sine 5x cosine 5x times 5 dx. But now it is extremely tempting, if you know your trig identities here, to do something with this 2 sine theta cosine theta expression. That's just sine 2 theta. And so what we actually end up with is that du is 5 sine 10x. Aha! That's exactly what we just have sitting there, except for the 5. So, if I stick in the 5 and undo the damage with a 1/5, then that entire first line becomes, well, no room for arrows. So I'll just kind of, that going up from that first line, this becomes 1/5 antiderivative 5 sine 10x dx is just my du, and this whole thing is just e to the u du. Ta-da! And the antiderivative of e to the u is just e to the u, so this is 1/5 e to the u plus c. So we get 1/5, our final answer is 1/5 e to the sine squared 5x plus c. It's also possible to do this thing in stages where you do some intermediate substitutions, but you should get the same answer. Okay, 19 we did already, 20 we did, so we're going to go to 21. Okay, 21 is, I think, maybe not so hard. X to the 4th over x squared plus 1. What's the sort of rule of thumb with rational functions? You do polynomial division whenever you can, and here we certainly can. And so, what is x to the 4th divided by x squared plus 1? Well, it's going to go in x squared times, and that will give me x to the 4th plus x squared. That gives me negative x squared, and x squared plus 1 goes into negative x squared negative 1 times, so that's negative x squared minus 1. When you subtract, you get 1. So I think I did that right. I think what we end up with is x squared minus 1 plus 1 over x squared plus 1. And this is the sort of the method you should always follow when you have a rational function. Did I do that right? Yeah, I did, because you can. Okay, well anyway, now it's just doable in one line. Antiderivative of x squared is x cubed over 3 minus x plus arctan. And that's the whole problem done. Okay. We did everything else on this page. We now go to page 6, number 24. Okay. What now? Well, okay. Let's just start. 1 over x root x to the 4th minus 4. Okay, this is kind of scary, I guess, because I don't have anything involving x to the 4th minus 4. I do have something involving x squared though. So based on my experience with this situation, I am going to write this as dx over x root, oh boy, x squared minus 4. How does that look? Could be worse. Well, sure. Okay, so why is that such a good idea? Well, because now I can do a substitution. The substitution is u equals x squared. And if I let u equal x squared, then du dx is 2x dx, and then du is, it's just 2x, so du is just 2x dx. Okay, and maybe now you're feeling a little bit like, oh man, this problem's not going to work, because I don't have 2x dx. But here's the sort of brilliant move. It's not brilliant, it's just algebra, I guess. If I need there to be a 2x dx up there, then actually this is a good opportunity to explore the sort of other kind of technique. Maybe this is actually better explained that way. There's the whole other kind of way of doing this, which some students like better, where you just solve for dx, And what is dx in this case? It's just du over 2x. And actually, what you can now kind of just do is just mindlessly plug in for dx du over 2x. And if you do that, you get x down here, and root x squared squared minus 4 down here. But then this x is going to cancel this x, and then so you just get du over 2. I don't actually like this way, but whatever. So what does this whole thing become? It becomes du over 2 root u squared minus 4. Alright, so however you get there, that's just the answer. And now I start to realize, oh man, it's just another one of these arcsine problems again. So we do it. Let's see. I pull out the 1/2. I get du over the square root of, inside the radical, I factor out a 4. So that's u squared over 4 minus 1. That was the whole point, was to make that a 1. I take that 2 out of the square root. It becomes a 2, so I end up with another 1/4 here. And this is now 1/4 antiderivative du over, I rewrite this as u over 2 squared minus 1. All of that is in the radical. And finally, I prepare one last substitution of w equals u over 2. dw is 1/2 du. So I stick in the 1/2 and undo the damage with a 2 on the outside. So what I really get is 1/2 antiderivative dw over root w squared minus 1, and that is just arcsine w. So I get 1/2 arcsine w, but okay, w is really u over 2, and u is really x squared, so x squared over 2 plus u. Alright, so that was pretty hard. You had to kind of see ahead a little bit. Okay, let's see, what's left? I think just 2 more problems. Good. 26. 26. Okay, this is just a drag. Well, let's just do it. Oh man, sad baby. Okay, 26. Dx over 3x squared plus 12x plus 25. Okay, experienced people will just look at this and see immediately that this is going to be some kind of arctan. Because all positive, well, that's not actually totally true, that's obvious that it's going to be arctan. We hope maybe that it will become arctan. Will it become arctan? Well, let me complete the square and see what happens. I think these numbers don't work out that nicely, so sorry. So let's factor out a 3. This is just algebra 1, but people find it hard for whatever reason. Zom zom plus 25. Okay. Good. That's just right, so that's good. What number goes here? Well, 4 goes here. So I just added 12, so I have to subtract 12. Okay, what thus do I get? I get dx over 3 x plus 2 squared plus 13. And now I'm starting to recognize that it's just going to be arctan. Okay, I like to simplify in little pieces as I go. So if u is x plus 2, then du is just dx. And so I'm going to seize the opportunity to simplify my life a little bit, and thus rewrite this as du over 3u squared plus 13. And now it's starting to look like arctan, But the problem is that this needs to be a 1, and it isn't a 1. So to make that a 1, believe it or not, now I have to just factor out a 13. So I get du over 13 times, 3u squared over 13 plus 1. Like I said, numbers are ugly, but it's all kind of making sense. Okay, but then I need to put this in the form like something squared plus 1. So here's where like I'm not so happy, because this is 1/13 du over, and I just got to do it, man. This is just root 3u over root 13 squared plus 1. In other words, I'm just forcing that denominator to be in the form that I need it in. Have I done this correctly? Have we done something wrong? No. No. This is all right. I guess I could have... Oh, I see. I could have done something different. But maybe this is the best thing to do. I don't know. I did something a little different on the enter key. Okay, anyway, proceeding. What do we do now? I'll just... well, I guess I can do it here. What's w? Well, it's just going to be this gross thing, right? This root 3u over root 13. Then what's dw? Well, it's just going to be the derivative of that, which is just root 3 over root 13 du. So I need to put in this numerator, this kind of gross root 3 over root 13, and I need to undo the damage with a root 13 over root 3. Okay, if I do that, I get root 13 over 13 root 3 times the antiderivative of, well, that whole top becomes dw, and the bottom becomes w squared plus 1. And so, what do I get? I get root 13 over 13 root 3 arctan w. And w is really that, so that's really root 3 over root 13 x plus 2, that's it, plus e. Let's see, yeah, that's just right? Why do I, oh boy, I'm now feeling like I made a mistake somewhere, but I'm really sad about that. Root 3 over, no, sorry, no mistake. Everything is more or less okay. Yeah, it's all right. Okay, I took it wrong on the enter key, so that's interesting. Okay, the last problem from this packet that I did not do in the original video that you have to do is this number 30. And I bet you can figure out how to do this. I want the antiderivative of cosecant. And, oh, we're going to get this in one video. What is the antiderivative of cosecant? I don't know. And once again, there's like a long, complicated way, and then there's like a cheap way. The cheap way is to think to do this trick because someone told you. And the trick is the analogous trick to the trick I did in the video, except now I want to do it with not secant plus tan, but cosecant plus cotan. If I just do this, man, don't ask why, then this becomes antiderivative of, while distributing through the top, gives me cosecant squared x plus cosecant x cotan x over cosecant x plus cotan x. and now I recognize that cosecant squared is almost the derivative of cotan. In fact, the derivative of cotan is negative cosecant squared, and the derivative of cosecant is negative cosecant cotan. Thus, if I guess I'll do it over here, if I let u be the bottom, if I let u be cosecant x plus cotan, then du is, like I said, the derivative of cosecant is negative cosecant x cotan x, and the derivative of cotan is negative cosecant squared. So what is du? It's just the opposite of cosecant x cotan x plus cosecant squared x dx. In other words, du is just the opposite of that numerator. And so if I stick a negative on the outside and a negative up here, then I get that this is exactly negative du over u. Yeah. And so what I get is negative ln absolute value of u, but u is cosecant x plus cotan x. And I guess people, for whatever reason, they just leave this one. And so there it is. Okay, that was number 30. We're getting in under the 33 minute mark, so that's nice. This will be one video. That was the homework on antidifferentiation. We are now very, very good at antidifferentiation. Why is it so important to be so good at antidifferentiation? I've not really told you yet. And more of that is coming next week. Okay, goodbye.